welcome to our classroom. It is the backyard. It's a bit of a mess in this area because I am in the middle of a project, putting down some pavers to make a little walkway. And one of the things that I have to do to make sure everything is straight is use something called the Pythagorean Theorem, which is your lesson for today, first one that I'm doing. The Pythagorean Theorem is named after an old Greek mathematician, say hi to truckers, named Pythagoras. And it's named after him, but it was actually, there's evidence of it being used by ancient Egyptians, Chinese, Mesopotamians. It just didn't get recorded until in an official way, and it didn't get set in the history books of mathematics and geometry until Pythagoras. So that's something that happens in our history books as we've learned before. As you can see, I've got some pavers going, and I am working on these sections here. I've got some concrete that I've already laid down when I had all my angles all worked out, but because of circumstances, some of which is our little friend Trucker right there chasing cats, once in a while he runs into these string lines that I've got to mark everything off, and he will knock them down a bit, and they're not so accurate anymore. So I am going to give a lesson here on the Pythagorean Theorem and how I used it to make these angles to begin with, and then you guys are going to get to do it at home, maybe not with pavers and stuff, but with whatever you decide to do. So, what is the Pythagorean Theorem? Well, it's based on the geometry of a right triangle. So we all know that a right triangle means that you've got a triangle that includes one right angle and, of course, two acute angles. Now, what I'm using it for is that I want to take this part of my path and head down this way, but I want to make sure that it comes down at an exact right angle. So how am I going to do that? Well, what Pythagoras and all those other guys came up with was that they figured out that if you take the square that you build one side of the right angle with and the square that you build the other side of the right triangle with, and add those two squares up, they would equal the square that you could build on what's called the hypontenuse, or the third side of that right triangle. So let me show you what I mean. I've got a 4 foot, I know it's 4 feet because I bought a 4 foot level. I've got a 4 foot level right here, so from end to end it measures 4 feet. I've got a piece of wood here that has 3 feet marked off to that measure there. So those are my two sides, or the two legs, and those of you guys that remember, we've got a minor leg and a major leg when we're talking about doing a right triangle. Those are going to be my two legs here. So what that means is the square built on the 4 foot side would be 4 by 4. 4 foot square going that way. The square over here would be 3 by 3. Well, what is 4 by 4? Let's think of our areas that we know to do. So 4 times 4, length times width for a square, that's going to be 16 square feet. So that's a squared. Those of you guys doing algebra. So this side, 4 by 4 squared would be 16. The 3 by 3, of course, would be 9. So if I was sitting, basically I'm sitting in the square that it would form, and that would be 9 square feet. So, do the math. 9 square feet plus 16 square feet is going to give you 25 square feet. Well, if you had 25 square feet, you can figure out what the sides of that square would be, right? Because what times itself gives you 25? 5. So I know that if this side is 4 feet long and this side is 3 feet long, then this angle that I'm making. This would be my vertex. This is one leg, that's the other leg. This angle that I'm making at this vertex right here is going to be 90 degrees when a 5-foot long measurement makes it from here to here, point to point, making the hypotenuse. Remember, the hypotenuse is the other side of the right triangle. Minor leg, major leg, hypotenuse. Right? So 3, 4, 5. What we call that is a Pythagorean triple. We call it a Pythagorean triple because it is one of the instances where we get whole numbers out of all this. Now you can do it with any measurement. You can make a right triangle with any measure legs, obviously. You can draw whatever you want. But when you make, say, a measurement here that was 2, let's say this was 2 feet and that was 4 feet. Well, 2 squared is 4, and 4 squared is still 16, and 4 plus 16 is 20. But there's nothing times itself that's a regular whole number that gives you 20. So that would end up being this decimal. And a lot of times they're what's called irrational decimals, and they just go on forever. So they don't help you as much as a Pythagorean triple, where everything works out a whole number, where it's 3, 4, and then 5, for instance. With 2, 4, that would be, I don't even know, it'd probably be 4.7, blah, 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 forever. So I want to work with the Pythagorean triples. And there's only so many of them. 3, 4, 5 is one of them. 5, 12, 13 is another one. And any multiples of those numbers. So you guys all know your multiples, right? What's a multiple of 3? 6. 6 is the second multiple of 3. What's a multiple of 4? 8's the next one. So if I go 6, 8, think of what the next multiple of 5 is, it would be 10. So I could have the sides be 6, 8, 10. Now I could have done that here too if I was doing a huge or twice as big a walkway. I could have 6 feet going that way, 8 feet going that way, and I would want to make a 10-foot hypotenuse. I don't need that. 3, 4, 5 works really well for me here, and feet works really well for me here. When you guys do your own Pythagorean Theorem practice and get your own Pythagorean triples going, you could do it in inches. 3, 4, 5 inches. You could do centimeters, 3, 4, 5 centimeters. Millimeters would probably be too small. I wouldn't recommend that. But you guys pick your own unit of measure. Remember, that's what all those are. Inches and feet, and yards and centimeters and all that. Those are all our units of measure, right? So let's get back to making sure this is a right triangle. So I've got 3 feet here, 4 feet there. I want to make sure it's 5 from the point to the point. And then I'll know where to put this string line back and hopefully get my pathway built before a trucker comes along and knocks it down again. So where do I want this to go? I know it's going to be somewhere around here. Like I said, I've already measured it off. So I'm pretty close as it is. But I got to measure perfectly from this point to that point and make sure that it is 5 feet long. I'm going to set this up a little higher. A couple more paver, just so I can raise this up so it's about in the same height as our other one. I think I'm going to switch it this way. Going back this way. That way, got it all in about the same height, and that's going to be important, I think. Alright, so the next thing I need to do is to go get my tape measure. Depending on how much time I take editing this, you're either going to get a long time me walking away, or it'll seem like I just got back. Alright, so I got my tape measure, and I'm going to set it out to 5 feet, where 5 feet shows. Lock it down so that way don't have to hold it. So you can see I've got it on here. I don't think the frame goes far enough in the shot for you to see that end. If you can, great. If you can't, I apologize, but you can rest assured that I've got it set up right on the end, on the corner of the 4-foot one. So, it doesn't quite line up here though. So that one's lined up perfectly. but my 5 feet and my 3 feet aren't exactly in the right place. So I got to adjust them a little bit, and while I do that, I am adjusting my angle. So that makes this angle over here, I had to move it over a little bit. That would take it, probably it took it from maybe 51 or 52 degrees, very small amount, but just enough where my 60 inches or my 5 feet lines up perfectly with my 3 feet. Right there. So that's still lined up. This is now lined up. That means that is a perfect right angle over there now, because it's 3, 4, and now 5 down the hypotenuse. So now I can make sure I put my stake right up against this right here. And that string line, as long as I follow it with my bricks as I go down this way, I know that I'm building a perfect right angle path right there. And then I have to get Trucker to promise. Trucker, come here. Come on. Well, he's busy. Eating, I don't know what. Sound familiar, huh? Well, he misses you. He promises not to knock our string line down. And we miss you guys, but that's your work for the Pythagorean Theorem. Everybody needs to build your own right angle out of something, whatever it is that you want to do. If you want to build it with squares, like I said, you can think of the different squares you would make. For instance, make something that is 3 by 3 as a square, and something that's 4 by 4 as a square, and then something that's 5 by 5 as a square, and put them all together, and you'll see how the Pythagoras and all the old mathematicians and geometry folks figured it out. Remember 5, 12, 13 is also a Pythagorean triple. You can work on doing it with other multiples. But build something that you know has a perfect right angle because you used the 3, 4, 5 or another Pythagorean triple method. Take a picture of it or make a little short video of you doing it and post it. And we'll all look forward to seeing what work you've done. But everybody needs to do something with the Pythagorean Theorem this week. Whatever it is that you choose to do. Alright, I gotta get building. I got some mortar to mix right behind where that camera is. I got some pavers to set down. And then maybe one day when we all get back together, I'll show you guys how this whole project came out. Alright, thanks guys.